I'm pregnant. Oh, my water's breaking.
Aaron, hurry up, man. Drive faster.
All right.
She's pregnant.
All right.
Come on, let's go. Aaron, hurry up.
I'm driving as fast as I can.
You need to go faster.
I'm trying to go fast and furious, man.
Let's go faster.
Excuse me, sir. Do you know why I pulled you over?
No, I don't.
You were speeding.
Well, we have a pregnant lady in the car, and we're just trying to get her to the hospital as fast as we can.
My water broke.
All right, I'm gonna give you a warning this time.
Thank you.
Don't do it again.
Oh, we won't.
Good.
Thanks for letting us off with a warning, officer.
Yes. The nearest hospital is 20 miles north.
All right, thanks. We'll go there right now.
Can't believe we got pulled over again.
I know it sucks. Kyle, are you okay?
Dude, he's pregnant.
You again.
Hey, I was going at a safe speed. I was traveling 45.
It's mathematically impossible for you to travel that distance at a safe speed.
Really? Where's your evidence?
I'll take you to my laboratory.
Go.
Welcome to my laboratory. I'm using the mean value theorem to prove that you were going over the speed limit. You may think the mean value theorem is just this arcane theorem that shows up in calculus classes. But at 5 o'clock, I pulled you over and directed you to a hospital 20 miles away. But 18 minutes later, I pulled you over again at 5:18. Let me draw this graph for you. Alright, so right here we have the y-axis labeled as S, and that's miles. We have the x-axis. It is the t in this situation, and that is also hours. Let's start labeling the graph now. I initially pulled him over at 5 o'clock, and then I pulled him over again at 5:18. But in order to graph this, we need to put this in hours, and 18 is obviously in minutes, so we'll just do 18 divided by 60, which gets you 0.307. Let me graph the y-axis. So I pulled him over initially at 5 o'clock. So S of 5 at 0 miles. 20 miles later at 5:18, which is actually 5.307 at 20 miles. Now on to the x-axis. First I'll start with 5 right there. Then I'll move on and say 6. But since I pulled him over again at 5:18, it's in between, so we'll do 5.307. Now, on to the actual mean value theorem of mean value theorem, which is f of b minus f of a all over b minus a, which is equal to f prime of c, or the instantaneous rate of change. Now we'll start by plugging in each component into the mean value theorem. We'll start with f of b, which equals 20 miles. Then we'll go with f of a, which equals 0 miles. Then we have a, which equals 5 hours. We have b, which equals 5.307 hours. Now we will plug each component into the formula. If you recall, the formula is f of b minus f of a over b minus a. So let's plug it in. We have 20 miles minus 0 miles over 5.307 hours minus 5 hours. Oh, this is equal to 65.145 miles per hour. So now I'm going to draw a hypothetical situation graph. Look right there. Okay. And so by the mean value theorem, f prime of c, or the instantaneous rate of change, equals 65.145 miles an hour. And in this hypothetical graph that is continuous and differentiable, we can see that the instantaneous rate of change occurs twice, and it happened at least once. Proven by the mean value theorem, you went over the speed limit at least once, speeding at 65.145 miles an hour, and the speed limit was 45, meaning you were speeding. Don't speed. Thank you!
Here's your ticket, sir. Calculus proved me right.
Dang it!
You were right, officer.
Kyle, you still pregnant?
Nah, bro.
You again!